Hey Caroline, this is in reference to your question with regards to when to use Z and when to use T in these questions that deal with probabilities about getting a particular mean or getting a particular proportion. The general rule that we were talking about this morning when we were working together is that Z is for proportions, T is for means. Now, you looked a little frustrated, so I didn't want to overwhelm you, but there's one exception when you don't have to use T for means, but rather can use Z. See, the T distribution exists because there are many situations when we do not know the standard deviation of the population. So we have to estimate it using the standard deviation of our sample. So T is for when sigma, which is the population standard deviation, is unknown. Which is most of the time when we're dealing with means. So when we're dealing with means, most of the time, we don't know sigma. And therefore, we have to estimate it using our sample standard deviation, which is why we are in the T distribution instead of the normal curve. Now, the one exception that we could use Z for means is when we do know sigma, which again is going to be very rare. So when we do know sigma, we see another formula on our formula sheet for Z for means. And notice the difference when you compare these two formulas, the formula for T and the formula for Z. The only difference is that with Z, we know sigma, with T, we do not, so we're using S. That's really the major difference. So 99% of the time, Caroline, we do not know sigma, which is, of course, the standard deviation of the population. So almost all the time, the standard deviation of the population is unknown. That's why the T distribution exists. Remember the whole story about William Gossett working for the Guinness Brewing Company and discovering the T distribution? That's what this is all about. Okay? Let me know if you have further questions.